Assalamualaikum warahmatullahi wabarakatuh. My name is Nurazian Binti Tugiman, Matric number 1620342. In this video, I'm going to present my final year project and the title is Investigation on Properties of Cement Paste Containing Palm Oil Fuel Ash Pofa as Partial Replacement of Ordinary Portland Cement OPC. This is the presentation outline. This project consists of 5 chapters, which are the introduction, literature review, methodology, analysis of data, and summary of work. Moving on to the first chapter, which is the introduction of this project. Nowadays, the palm oil industry has been getting a lot of demand for domestic and industrial use. This will cause excessive production of Pofa. Unused Pofa, if it is being disposed without a proper handling, it will cause disruption to the environment. Also, currently, we can see that the construction industry is developing rapidly, and due to that, a lot of structure will be constructed and cause excessive usage of OPC. OPC production will generate about 5% to 6% of carbon emission, and carbon dioxide is one of the harmful gases generated from it. The carbon dioxide emission will affect the climate changes as it increases the temperature of this world. Therefore, to overcome those two problems, the utilization of Pofa as partial replacement of OPC has been proposed. In this research, there are 3 objectives that have been focused on, which are to establish the properties of fresh cement paste due to the partial replacement of OPC by Pofa. Secondly, to determine the compressive strength of cement paste incorporating various percentages of Pofa as partial replacement of OPC, and thirdly, to analyze the water absorption properties of cement paste with OPC replaced by Pofa. Pofa is a waste that has been generated from the palm oil production. Also, Pofa can be recycled and it can be used as partial replacement of OPC. This is because Pofa contains pozzolanic materials as it has fine structure and it contains silica or alumina. Moving on to the next chapter, which is the literature review. For the fresh property of cement paste, these 2 authors have concluded that the setting time will be increased as the percentage of Pofa increase. Next, for the hardened property of cement paste, these 2 authors have reported that the compressive strength will be reduced as the percentage of Pofa added into the mixture increase. Lastly, for durability property of cement paste, these 2 authors have mentioned that the usage of Pofa in a cement paste mixture will cause the cement paste to be less permeable to water. Chapter 3 explains about the methodology used in this research. There are 4 types of cement paste that have different percentage of Pofa, which are 0, 5, 15, and 25% of Pofa. The cement paste that have 0% of Pofa is considered as the conventional cement paste, while the remaining cement paste is considered as improvised cement paste. There are 3 materials needed to produce the cement paste, which are the cement, OPC, Pofa, and also water. The mixture proportion of cement paste was determined according to the correlation of water to cement ratio, and the water to cement ratio used in this project is 0.5. And then the materials were weighed according to the weight that have been calculated from the mixed design. Next, all materials were mixed by using the mortar mixing machine, and then the fresh cement paste will be tested on its workability by conducting setting time tests. Setting time consists of 2, which are the initial setting time and final setting time. Initial setting time is the time taken for the cement paste to start harden. Meanwhile, the final setting time is defined as the time taken when the needle failed to penetrate the surface of the cement paste. After that, the fresh cement paste was put into the water curing tank for curing process. The water curing method is used to help to retain the moisture in the hardened cement paste for development of compressive strength of the cement paste. When the cement paste has hardened, there were 2 tests that have been conducted, which are the compression test and water absorption test. Both tests were conducted at 7, 14, and 28 days of curing. For compression test, it was conducted by using the digital compression testing machine, and it was conducted at 3 different ages of curing to observe the development of compressive strength of the cement piece. And for water absorption test, the samples were taken out from the water curing tank and put into the oven for the oven drying process 2 days before the test was conducted. After it is oven dried, the weight of the sample will be recorded. Also, after oven dried, the sample will be immersed in the water for 30 minutes, and then the weight will be recorded too. The percentage of water absorption will be calculated through those two weights of sample. Table shown in the slides is the mixture proportions that have been calculated through the correlation of water to cement ratio. Moving on to the next chapter, which is chapter 4, analysis of data. To observe the property of cement paste, setting time test has been conducted, and from the test that has been conducted, it is proven that the initial and final setting time increase as the percentage of Pofa added into the mixture increase. Also, initial and final setting time will affect the workability of the fresh cement paste. This means that when the initial and final setting time is longer, it increases the workability of the fresh cement paste. This will slow down the process of hydration of the cement paste, and it will take longer for the cement paste to set, and this will ease the working process of cement paste in the construction. However, from the graph, it can be seen that there was a sudden increment of the initial and final setting time when 5% of Pofa is added into the mixture, and this may happen due to the inconsistency of the size of Pofa particles in each mix. Next, to determine the hardened property of cement paste, compression test was done. From the result shown in the slides, it can be seen that the conventional cement paste have achieved a higher compressive strength as compared to the improvised cement paste. The cement paste will be decreased due to several factors such as the improper transfer process of fresh cement paste from the mixing bowl to the mold, and the improper mixing of fresh cement paste. These factors will cause the component of materials of cement paste to be isolated from each other, therefore it decreases the compressive strength. However, by comparing the compressive strength of the improvised binder, it is found that the compressive strength will be reduced as the percentage of Pofa increase. Therefore, it can be concluded that the maximum percentage of Pofa for partial replacement of OPC is only 5%. Lastly, to analyze the durability property of cement paste, water absorption test was performed. From the result shown in the slides, it can be seen that conventional cement paste has the least percentage of water absorption as compared to the other improvised cement paste. However, by comparing only among the improvised cement paste, the percentage of water absorption will be increased as the percentage of Pofa added into the mixture increased. The percentage of water absorption may be affected due to the size of Pofa particles. This is because fine particles of Pofa will have a very less porosity, and it absorbs less water into the hardened cement paste. And to conclude, the maximum percentage of Pofa to replace OPC is only 5%. Moving on to the last chapter, which is the summary of work. In conclusion, all objectives have been achieved. The first objective is to observe the fresh property of cement paste by conducting setting time tests. It is concluded that the workability of fresh cement paste is highly dependent on the initial and final setting time of the fresh cement paste. As the Pofa added into the mixture increases, the initial and final settling time will be increased too. The second objective of this project is to determine the hardening property of cement paste by conducting the compression test. Compression test was conducted at 3 different ages of curing, mainly to observe the development of compressive strength of the hardened cement paste. Also, it is found that the compressive strength will be reduced as the percentage of Pofa increases. This is because when the percentage of Pofa is high, the amount of CaO content in OPC will be low, and it slows down the process of hydration, therefore it reduces the compressive strength of the cement paste. Lastly, to conclude, the optimum percentage of Pofa added into the cement paste mixture is only 5%. And the third objective is to analyze the durability property of cement paste by conducting water absorption tests. It can be concluded that the percentage of Pofa used as partial replacement of OPC has affected the percentage of water absorption. This is because the percentage of water absorption will be increased when the percentage of Pofa increases. The percentage of water absorption has been affected by the age of curing. As the age of curing increases, the percentage of water absorption decreases. This is because as days passes by, the voids and the porosity of the hardened cement paste has been reduced, thus less water to be absorbed by the hardened cement paste. To conclude, the optimum percentage of Pofa that can partially replace the OPC is only 5%. Also, there were some limitations that have occurred while performing the test in this research. The first limitation was when the cement paste with 0% of Pofa produced the most durable cement paste as compared to the other improvised cement paste. However, in the future research, same size of particles of OPC and Pofa should be used as the particle size affected on the porosity of the hardened cement paste. The second limitation is the time constraint to conduct the test at the 90th days of curing. So, in future research, it is recommended to do the test at the 90th days of curing to determine the full development of strength and the performance of the hardened cement paste. And that's the end of my presentation. Thank you.